Welcome back to my channel. This is Pragya, and today we are covering the topics of internal 3. So in first video we have covered 15 questions. Now this is the second part. We are covering the rest 15 questions. So let's get started. So the first is, what is the main purpose of data imputations? A. To remove records with the missing data. B. To estimate missing values based on available data. C. To detect outliers in the dataset. D. To convert categorical data into numerical format. So the correct answer is the B. To estimate missing values on the available data. So you have to estimate the missing value. If some value is missing, you have to detect those missing value. You can use KNN or many other methods for that. So the second question will be, which of the following method is commonly used in outlier detections? K-mean clustering, Z-score, random forest imputations, mean max scaling. So we have used a Z-score method for used to detect outlier detections. The question third will be, which statistical distribution is commonly used to model the number of success and fixed numbers of independent trials with the sample probability of success? A. Normal distribution. B. Poisson distribution. C. Binomial distribution. D. Power law distribution. So the correct answer will be binomial distribution, because in binomial distribution you can use 0 and 1 for the success or the failure. The question number 4 will be, what does mean value imputation measure about the data when the filling missing values? A. Missing value should be replaced with the value with the most accurately represent the missing feature. B. Missing values are randomly distributed and can be replaced with a random number. C. Missing values should be filled using the values of nearest data points. D. Missing values are best left unfilled and excluded from the analysis. So the D option has directly deleted because you cannot just left the missing value, and the first one will be the correct option according to me, because the missing value should be replaced with the value that most accurately represent the missing feature. Suppose we have a table containing data sets and one value is missing. So you have to put the value which is accurately according to your need of the model that represent and most accurate the missing value that can represents the missing feature in the model. Now we have the fifth question is, which of the following is a common technique for filling missing values when using mean value imputations? A. Replace missing values with the mode of the data. B. Replace missing values with the random value. C. Replace missing values with the mean of the known values in the dataset. D. Replace missing values using the nearest neighbor of each data point. So the correct option will be C. Replace missing value with the mean of the known values in the datasets, because the mean cannot contain the outliers. Now the question number 6 is, what is the bias variance trade-off in machine learning model? So the correct option will be the B, the trade-off between unfitted and overfitted, which increase the model complexity, can reduce the bias but increase variance. The question number 7 is, if you are working with a dataset where some numerical features have extreme values that may appear to be errors, which of the following methods will be appropriate for the outline detection? Run a sanity check and examine the data for outliers. Perform linear regression in all features. Apply mean value imputations to the outliers. Use a hot encoding to transform the outliers into categorical values. So the answer will be A. Run a sanity check and examine the data for outliers. Suppose you have a data set containing salary of employees, and every employee's salaries range between 50,000 to 1 lakh, but one employee has a salary of 10 lakh rupees. So this is the extreme value. So you can run a sanity check and examine the data for the outliers that this particular employee have higher value than the others. The 8th question will be, if your dataset contains a feature of continuous and discrete features, you need to scale the continuous feature. Which of the following techniques should you apply? So the technique should be applied z-score for scaling normalized continuous features. Now we have the ninth question, which says that which of the following is the feature engineering technique used to handle categorical data? Binding the data, mean value imputation, one hot encoding, random value imputation. So the correct answer will be one hot encoding. The question number 10 that says that after performing data imputation using the mean, you notice a significant skew in your feature distribution. What will be an appropriate next step? Leave the data as is. Since imputation the mean is a widely accepted method, try imputing with the median to reduce the effect of skewness. Remove the feature from the datasets to avoid skewness. Apply one hot encoding to transform the feature. So the correct answer will be try imputing with the median to reduce the effect of skewness. The 11th question says that a dataset with missing value contains both continuous and categorical data. Which of the following imputation methods will be the most appropriate for the categorical values? So the correct answer will be heuristic based imputations, because the categorical data contains random values. So the heuristic based imputation will be the best for it. With the 12th we have is the linear regression model is the coefficient of a predictable value is 0. What does this imply about the relationship between the predictor and the response variable? There is a strong positive relationship. B, there is a weak negative relationship. C, there is a no relationship. D, the predictor is relevant to the model. So the correct answer will be there is no linear relationship. The question number 13, you are using feature engineering to improve machine learning model. Which of the following strategies would you help to improve the model performance? So I think the correct option will be the C, because the feature creating interaction features such as product of two important variables will help you to improve the model performance. The question number 14 will be, when conducting features engineering of a machine learning model, which of the following would be considered the best practice? A, create as many features as possible to increase the complexity of a model. Transform raw data using domain knowledge to create new meaningful features. Apply random value imputations for all missing values. Resolve an automated feature selection without human input. So the correct option will be B, transform a raw data using domain knowledge to create new and meaningful features. Suppose you have a raw data of any website or any server. You can transform that raw data using domain knowledge to create a meaningful feature so that it can be further analyzed and can be used by many people for more computation process. The 15th question will be, you are building a model to predict housing prices and you are using a parametric model. Which of the following is the assumption made by the model? A relationship between the input features and the output is known and flexible. B, the relationship between the features and the output is linear and fixed. C, the model will dynamically change its forms based on the data. D, the model has no assumptions about the distribution of the data. So the correct option will be the B, the relationship between the features and the output is linear and fixed. So that's it for the video. We have completed all the questions of internal 3. So thank you. I hope you understand.